Hello, my name is Enrique, and I'll be teaching you what factorials are and equations involving them. In math, the exclamation point is a symbol for factorial. Factorials are a function in math, where we use the coefficient as the starting number and multiply by all the numbers descending until 1. In this example, 4 factorial, we can expand this to 4 times 3 times 2 times 1. And to solve, you just multiply, which gives you an answer of 24. In another example, in parentheses 15 minus 10 factorial, we do parentheses first, giving us 5 factorial, and that turns into 5 times 4 times 3 times 2 times 1. And to solve this, we just multiply, giving us 120 as our final answer. What about fractions? Well, we'll just expand the functions and see what cancels out. So in this example, 9 factorial over 5 factorial, we expand both the functions, and the 5 times 4 times 3 times 2 times 1 reduces to 1 on both the numerator and the denominator. And then we just multiply 9 times 8 times 7 times 6. That gives us an answer of 3024. Finally, if we look at an equation 2 factorial 3 factorial, first we have to expand both the functions, grouping up 2 factorial and 3 factorial separately to become 2 times 1 in parentheses and 3 times 2 times 1 in parentheses. And then we solve both these parentheses, giving us 2 and 6, and then we multiply that, and that gives us 12 as our final answer. Now, if we combine fractions and operations in one problem, we have 3 factorial 7 factorial over 6 factorial 4 factorial. And what we can do is expand the functions to get values to cancel out. 3 factorial can stay as 3 factorial. 7 factorial can turn to 7 times 6 factorial, because we just expanded it. And 6 factorial can also stay the same. And 4 factorial can turn to 4 times 3 factorial. The 3 factorials and the 6 factorials both reduce to 1, and that leaves us with 7 over 4. Now other operations involving factorials, like n plus 3 factorial over n factorial. This turns into n plus 3, n plus 2, n plus 1, n factorial, all over n. The n factorial reduces to 1, and we're left with n plus 3, n plus 2, n plus 1. We can distribute this to find the answer, which is n cubed plus 6n squared plus 11n plus 6. We can also solve 3n plus 2 factorial over 3n minus 1 factorial. Our goal is to cancel out some values. So if we expand the functions, we can cancel out the denominator. So if we expand the functions to 3n plus 2, 3n plus 1, 3n, and then 3n minus 1 factorial, all over 3n minus 1 factorial. The 3n minus 1 factorial reduces to 1, and we're left with 3n plus 2, 3n plus 1. We can distribute this to find our final answer, which is 27n cubed plus 27n squared plus 6n.
1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. If we divide the answer by the coefficient, we get the answer of the previous factorial. 120 divided by 5 is 24. 24 divided by 4 is 6. 6 divided by 3 is 2. 2 divided by 2 is 1. 1 divided by 1 is 1. So 0 factorial equals 1.
What about a negative factorial? Watch the next video to find out.